Hello, today we're going to talk about mole-to-mole stoichiometry. So stoichiometry is still just conversions. It's just going to relate one compound to another. We are going to have to use a balanced equation for these, and we're going to use our mole conversions as well. So if you know the moles of one substance, using a balanced equation will let you figure out how many moles of any other substance in the reaction you would either need or you would yield. So if we look at our nitrogen-hydrogen reaction, this is also called the Haber process. 1 mole of nitrogen plus 3 moles of hydrogen is going to give us 2 moles of ammonia. So we can relate our moles of substance using coefficients from the balanced equation to write conversions called mole ratios. Remember, a ratio, you're going to have one thing over another, but they're both going to be essentially equal to each other. So just like when we do our mole conversions and we're using volume, 22.4 liters is equal to 1 mole. So we can write 22.4 liters over 1 mole. So if we're going to use our balanced equation, that means for every 1 mole of nitrogen, we're going to have to use 3 moles of hydrogen. So we could write a mole ratio relating those two things. These mole ratios are going to let us get from moles of one substance to moles of another substance. So you've got to use your dimensional analysis here. You've got to be writing not only your units, but also the substance that you're referring to, so you can keep things straight for your final answer. Also, using this will help you figure out what your next step is going to be. So if we look at our Haber process again, let's write some of these mole ratios. So let's say we wanted to relate nitrogen to hydrogen. Remember, the unit that you want would go in the numerator. The unit that you have is going to go in the denominator. So if you want nitrogen and you have hydrogen, that means your nitrogen is going to go in the numerator and your hydrogen is going to go in the denominator. So now looking at the balanced equation, coefficient for nitrogen is 1, so we have 1 mole of nitrogen, and the coefficient for hydrogen is 3 for every 3 moles of hydrogen. So that's 1 mole ratio that you can possibly use. Depends on what the question's asking you and what they have given you as to what your mole ratio would actually be. So let's look at a mole ratio for ammonia and hydrogen. So if you want ammonia is going to have to go in the numerator. And let's say you have hydrogen, so hydrogen is going to go in the denominator. Coefficient for ammonia is 2, so that means for every 2 moles of ammonia produced, now you find your coefficient for hydrogen, you had to use 3 moles of hydrogen. So mole ratio is going to come from the balanced equation. The unit that you want is going to go in the numerator. The unit that you have, substance that you have, is going to go in the denominator. And you're going to use the coefficients from the balanced equation to write your mole conversion. So the value is going to come from the balanced equation. That's what you're going to use to write your mole ratio. Sorry, I meant mole ratio. To get from one substance to another. So a general equation for mole-to-mole stoichiometry. Mole-to-mole means that you are starting with a mole of a substance and you're going to end with a mole of a substance. So if you have X moles of your given substance, you're going to multiply it by your mole ratio here. That comes from your balanced equation. Okay. The A and the B are the coefficients. These are going to be the coefficients. The W is going to be what you want, and the G is going to be the given. So X is the value that you're starting with, G is your given substance, W is the wanted substance, the one that you're trying to get to. And A and B are going to be the coefficients from the balanced equation. They're what's going to write your mole ratio here. All right, so let's try a problem. How many moles of ammonia are produced when 0.60 mole of nitrogen reacts with hydrogen? Now, for these reactions, for these problems, you'll always be given the reaction. It may not always be balanced, it may not always be completed, it may be in the word form, but you will be given a reaction. You have to have a reaction to do full stoichiometry. So, we need to find what we have been given. And we have been given 6.0 moles of nitrogen. And what are we trying to find? We are trying to find moles of ammonia. So first thing we need to do is write down our given. 0.60 mole of nitrogen. Now, what are we trying to get to? We're trying to get to moles of ammonia. Since we have moles and we're trying to get to moles, we can just use our mole ratio. So since we're trying to get to ammonia, you're going to have to look at coefficient for ammonia. That's what we want. That's going to go in the numerator. 2 mole NH3. We're trying to get rid of nitrogen here, right? Trying to get rid of moles of nitrogen. So moles of nitrogen is going to have to go in the denominator. Coefficient here, since there isn't one written, is understood to be a 1. So now you can see that your moles of N2 unit cancels. You're left with moles of NH3, which is what you are trying to find up here. So our answer is going to be 0.60 times 2. And we're going to have 2 sig figs. Got 1, 2 sig figs here. So that's going to give us 1.2 mole NH3. All right, let's try another one. How many moles of oxygen are required to make 0.835 moles of water? Here's your reaction. H2 plus O2 yields H2O. This one I did not give you the balanced equation, so we are going to have to balance it first. So we're going to need 2 oxygen for the water, and that makes 4 hydrogen, so you're going to have 2 in front of the hydrogen. Okay, let's look at what we're given and what we're starting with. So we are starting with 0.835 mole of water, and we are trying to find moles of oxygen. So the only things we're going to be using in this problem are the oxygen and the water. So we're going to write down what we have been given. We have 0.835 mole water. What are we trying to get to? What are we trying to find? We're trying to find mole of oxygen. What unit are we trying to get rid of? We're trying to get rid of mole of water. That's going to go on the bottom. Now look at your balanced equation. What's the coefficient for oxygen? Coefficient is 1. What's the coefficient for water? Coefficient is 2. Since you're trying to find moles of oxygen, and that's what we have here in our numerator, moles of water cancel out, you don't need any more steps. We can now solve. So 0.835 divided by 2. How many sig figs do we need? 3. 1, 2, 3. So our answer is going to be reported as 0.418 mole